All right, so let's do an activity first. You're going to give me both of your arms. Okay, so you're going to give me both of your arms. You're going to hold your arms at the 3 o'clock position. So everyone take out your both arms and then go like this, 3 o'clock. This is where 3 o'clock is. Your 3 o'clock, that makes mine. Okay, so you're going to keep your right arm wherever it is, and then that is called the initial side. So this side does not move. And then what you're going to do is you're going to move your left arm whichever angle I tell you to move. Okay, so first show me 90 degrees with your arm. All right, you guys are, oh, McKenna on the wrong side. Yeah, okay, and then 180 degrees. Okay, very good. 45. Oh, you guys are good. 30. Okay, a little shorter. 60. 120. Okay, I'm going to do a trick question. Negative 90. Negative 90. Negative 90. What's negative 90? All right. Talk to your partner. What's negative 90?
It's down there. Do that. Wait, exactly. I already did it.
As long as I get tired.
Me too.
Negative 90. All right, show me negative 90.
I can't do it. It's so...
This side of people says it's not possible. These sides, it's like this right here. Okay, yes, it is like this. So there was a reason you went like this, right? It's because I said the initial side doesn't move, so this is the 0. And then, so when you're going like this, that was the positive. And then, so when you go the other direction, it's the negative. Okay? All right, so let's go ahead and write all that information down. Okay, initial side is the side that the angle starts. And this is always going to be 0 degrees. Terminal side is where the angle ends, and it could be positive or negative, which we're going to talk about that right now. But initial side does not move. It never moves. It is at 0 degrees. No. Initial side is always 0 degrees. Yeah, it's always 0 degrees, and it's always on the right side, the 3 o'clock part. It doesn't move. All right, so let's go ahead and draw this. Okay, so the initial side is always here. So this is the initial side. And we call this 0 degrees. The terminal side is the one that's going to move. Okay, the terminal side could be here. So the terminal side could be there. Now, if it's over there and you're turning this way, we call this positive. So if it goes counterclockwise, so against the clock, we call that positive. The terminal side could end here as well. And if you turn this way, it's going to be negative. So if you turn this way, not where it lands, but how did you turn it? Okay, you could get to the same terminal side by turning positive, right? You could get to the same terminal side by turning positive or turning negative. So it's not where it lands, but how did you turn it? How did you turn to get to that angle? All right, so let's do some practice. But before that, let's write some notes in. So key takeaway. Standard position angle starts on the positive x-axis. Okay, positive x-axis just means the 3 o'clock position, because like if you think of it as a coordinate axis, it's starting on the positive x-axis, positive part of the x-axis. So that's where all the angles start. Positive angles turn counterclockwise. Positive angles turn counterclockwise. All the positive angles turn counterclockwise. Negative angles turn clockwise. Okay, negative angles turn clockwise, so going with the clock. Okay, going with the clock. All right, so let's go ahead and sketch these angles. So first we need a coordinate axis. And then once we do that, you want to draw your 0 degrees. So that is your initial side. And then you're going to draw your terminal side. Now this one says 140. 140 is a positive number. So where is positive 140? Like this, right? So 140. So what we're going to do is just draw that and then write 140. All right, let's go ahead and have you practice number 2 and 3. All right, so let's finish. Okay, 85 is a positive angle, so we're gonna go this way, and it's not past 90 degrees, so right here. And then negative 150 starts on the 0 and goes this way, so negative 150, sorry. All right, next. Okay, coterminal angles. So when you see the word coterminal, so remember when we were in like the conic section, we had a lot of co stuff or a little bit of co stuff like co-vertex. So co usually means along with the old one, right? So coterminal, well, what does terminal mean? We kind of just talked about it. Co or just terminal. The one that's moving, the side that it ends on, right? So coterminal means the side that ends, so another angle that ends on the same side. Okay? Another angle that ends on the same terminal side. So for example, let's say I have an angle that is 45 degrees. What's another angle that ends on the same side? What's another angle that ends on the same side? If I have 45 degrees, what's another angle that ends on the same side? Huh? Negative? Negative what? Negative 435?
45.
Negative 45 is right here though. 145? Huh?
315.
315, yes, yeah. 315. So if you go negative 315, you're back here. How did you know? 360 is the degree of, or the degree of the whole circle. What you're doing is you're going backwards 315, but basically 45 from where it should stop. Okay, so basically if you go 360, you would go back to the 0 degree, right? If you go backwards 45, you would be at 315. Okay, what's another one? What's another angle that ends on 45 degrees? What's another angle that ends on 45 degrees? That is not negative. Say that again. 135. 135 is here though, in the second quadrant. What's another one that ends on the first quadrant, 45 degrees? Okay, so let's think about it. In order to end on the same place, what do I have to do? I have to go 360, right? So it ends on the same place.
405.
Not 435. 360 plus 45. 415? Isn't it 405? Okay. 45 degrees is my terminal side, right? What's another angle that ends on the same side? In order to end on the same side, I have to start here and then go around the circle one whole time, right? Around the circle one whole time, a circle is 360 degrees, right? So it's 45 plus 360.
405. Yeah.
405.
Yeah, 405.
Oh, I thought you guys said 415. 405? Yes. What's another angle that ends on the same side?
360 plus that.
Yeah, so basically I can keep going around the circle forever and ever and ever, right? And then I will always end on the same side. Now, I don't have to always go in the positive direction. I can always go in a negative direction as well. So start on 45, minus 360, minus 360, minus 360, and I can do that forever. Right? So all of these will end on the same side. Okay, so let's go ahead and write that down. So a coterminal angle is the same angle. So if you end on the same side, and how do you do that? You add 360 degrees, and then times n meaning how many times you turn around that circle. Or you can subtract 360 and n again means how many times you go around the circle. So n is actually going to be an integer because it represents how many times you're going around the circle. So n is an integer. And eventually, you need to write n equals integer. Because if you don't, you're just saying n can be any real number. And that's not true. It has to be an integer. All right, so let's go ahead and have you, I will show you this one first. Which one of the following angles is not coterminal with the other three? Which one does not end on the same side as the other three? Now, you could draw it out and see if they all end on the same side, but that is not the fastest way. What you want to do is just make sure that they are all within 0 to 360 and then compare. Okay, so for example, first one, 300 degrees. Is that between 0 and 360? Yes. All right, just leave it alone. B, negative 60. Is that between 0 and 360? No, it's a negative and it's not between 0 and 360. So how do we check what kind of coterminal it is? At 360. Okay, because we know that it is the same angle as if we just turn one more round around the circle. So just add 360 to it. It is 300 degrees. So now we can see that it is the same angle as the first angle. So negative 60 is the same as 300 degrees. Okay, ends on the same place. All right, 60 is already within 0 to 360, so leave it alone. D, negative 420. Is that between 0 and 360? No, so what do we need to do? Add 360. All right, so if you add 360, it is negative 60. So it's still negative. What should we do? Add another 360. All right, 300 degrees. Okay, so which one is not the same as the other one? C. Okay, so this is how you check. It will be the fastest way to check. All right, let's have you practice which angles are coterminal. Which ones are the same? Which ones are going to end at the same place? All right, so the question is which angles are coterminal? So we have to change all of them into something that's between 0 and 360. So the first one is a negative number. We're going to change it. So this becomes 45 degrees. B is already within 360. C is within 360. D is more than 360, so we're going to subtract 360. And that is 45 degrees. So the only one that is not coterminal is C. So the ones that are coterminal are A, B, and D. Make sure you read the question. It is asking you which ones are the same, not which one is not the same. So please be careful. All right, next, let's have you practice. Give two angles that are coterminal with the following. Write two angles that are coterminal with the following. All right, so number one. All of these, as long as you add 360n or minus 360n, then you will get your answer. Okay, so sample answers 410 degrees, minus 310 degrees, or any of those coterminal angles if you keep adding 360 or keep minusing 360. Number 2, so common answers are 60 degrees and minus 660, or any other equivalent ones. Make sure you have a degree sign. Okay, next part, the most important part of the lesson for the next few weeks, which is the unit circle. So every day you come in, I'm going to make you fill one out. We're going to have a quiz next week. You have to fill this out within 5 minutes. So within 5 minutes, I stop the timer, and then you have to turn it in. And however much you finish is how much grade you'll get. But we're going to practice this every day, so then you have to get faster and faster every day in filling this out. Okay, so unit circle, you need to recall SOHCAHTOA. SOHCAHTOA. How many people remember SOHCAHTOA from algebra? Okay, or last year I think you guys did SOHCAHTOA, maybe very briefly. What does SO mean? S-O-H. Sign. S means sign, and then what does? Okay, O means opposite, and then over hypotenuse. All right, so this only applies to a right triangle. Only right triangle. SOHCAHTOA can only be on right triangle. And what happens is if you have an angle, in a right triangle, there's one right angle and then 2 non-right angles. You pick an angle and then you say, from this perspective, if I stand on this angle, which side would be opposite side of that? Right, the farthest away, right? And then which side would be adjacent, meaning next to? The one that's next to, right? Well, there are 2 sides that's next to. So what do we call that other side? Hypotenuse. And why is it called hypotenuse and not adjacent? Because hypotenuse has a very special meaning. Hypotenuse is always opposite of the right angle, and it's always the longest side. So hypotenuse cannot change. So that's why it's not called adjacent, okay? All right, so sine is opposite over hypotenuse. What is cosine? Cosine is ca, C-A-H, ca. C means cosine. What does A and H represent? Adjacent over hypotenuse. And the last one is TOA, tangent. T and TOA means tangent. So TOA means what? O and A means what? Opposite over adjacent. All right, so we have to memorize that. Now, there are some special angles in geometry that you learned last year. There was the 30, 60, 90, and the 45, 45, 90 triangles. How many people remember that one? Do you remember the ratio that goes with that one? No. Okay, that's okay. All right, let's start with the 30, 60, 90. 30, 60, 90. So the way I remember it is this is the 1, 2, 3 triangle. So opposite of 30 degrees is 1. Opposite of the right angle is 2. And then opposite of the 60 degree is 3, but it's not 3. Obviously, it cannot be the longest side. It's a square root 3. So it turns out to be a 1, 2 square root 3. But I just remember it as 1, 2, 3, and then just remember I need to put a square root on it. Okay? All right, let's look at the 45, 45, 90. 45, 45, 90 is an isosceles triangle, isosceles right triangle. So then in this one goes 1, 1, 2. So 1, 1, 2. Yeah, so it's not quite 1, 1, 2. It's not the correct ratio. It's 1, 1 square root 2. So the ratio is not like very, I guess, nice. 1, 2, 3 or 1, 1, 2, but you have to remember which one has a square root. All right, so these are the general triangles. However, when we go to the unit circle, it's a little bit different. But let's fill out all the angles first. Okay, so do you know where the 0 degrees is? It's basically where the initial side is. Can you guys point to where 0 degree is? Yeah, over there. So this is 0 degrees. Okay. Do you guys think you can fill out the 90 degrees, 180 degrees, and the 270 degrees? Where's 90 degrees? perpendicular, right? 90 degrees. And then 180 degrees over here. And then on the bottom, it's basically 180 plus 90. 180 plus 90, so that is 270. You're not used to 270 yet, but you will be. 270 is on the bottom. Next, let's fill out the 45 degrees. 45 degrees is halfway between 0 and 90, right? So that is 45 here. And the interesting thing is, you start at 0, add 45 to get to 45, add another 45, you get to 90. So you add another 45, you get to this angle, and what is that? Huh? 135. Okay, 135. You add another 45, you get to 180. Add another 45, you get to halfway in between, and so 180 plus 45. You might want to use your calculator right now. What's that? 225. Add another 45, you get to 270. Add another 45, 315. And then add another 45, you get back to 360. All right, good. Next, the angles that we are not familiar with. So you can see why we need the 45, 45, 90 triangle, because there's a lot of 45s in the unit circle. The next thing we're going to do is we're going to go in the interval of 30, which is why we need the 30, 60, 90. Okay, 30 degrees is here. This is the smaller angle, so that is 30. And then we're going to go up by 30. So 30 plus 30 is what? 60. So that goes here. 60 degrees. Sorry. 60 degrees. Okay, so starting from 0, add 30, you get to 30. Add 30, you get to 60. Add another 30, you get to 90. Add another 30, you get to where? 120. And then add another 30. 150. Okay. Add another 30, you get to 180. Add another 30. 210. These numbers are not familiar to you right now, but it's going to become super familiar to you that you know which numbers look right and which numbers look wrong. Okay, 210 plus 30. 240 plus another 30 is 270 plus another 30, 300, and then add another 30, 330, and then add another 30, get back to 360. Good? All right. Next, the reason we call this a unit circle, so this is called a unit circle. Obviously, first, it's a circle, so there's a circle in the name. There's the reason that it's called a unit is that it is 1 unit long in the radius. So the radius is 1 unit long, meaning it's 1. So this radius is 1 unit long. That's why it's called a unit circle. So let's do the easy one first. So these the points on these unit circles have coordinates. So we have to figure out what the coordinates are. First, let's start here. So right in the center of the circle, that is 0, 0. And we know that this radius is 1 unit long. So what is the coordinate at 0 degrees? 1, 0. Okay, let's go to 90 degrees. What is the coordinate on the 90 degrees? 0, 1. So the direction or the pattern or The way I'm filling it out is the way you want to fill it out on the unit circle when I give you practice, because this is from the easiest part to the hardest part. Okay, so 0, 1. All right, 180 degrees. So if this were 0, 0, this is the center, which is 0, 0. What is the coordinate on the 180 degrees? Negative 1, 0. Okay, last one. What is the coordinate on the 270? 0, negative 1. All right, next. So that was the easy ones. Now we're going to do the hard ones, which is, let's do the 45s first. 45. So we're going to remember our 45, 45, 90 triangle, because essentially this is the triangle like that. Okay, this much is 45. From the 0 degree to that line is 45 degrees. And that is a 90 degrees because I drew a straight line down. So this part has to be a 90 degrees. All right, so basically this is a 45, 45, 90 triangle. And we need to figure out how long is the x part and how long is the y part. And that has to do with our 45, 45, 90 triangle. Now, let's look at this a little bit. Okay, so we are going to use the measurements on this triangle. However, our radius is what? How long is our radius on the unit circle? 1. So then this hypotenuse has to be 1. Therefore, I need to divide everything by square root 2. Okay, and then this is going to turn out to be my x and y. But we never write it like this. We always rationalize it, so kind of recall how to rationalize fractions. We multiply top and bottom by square root 2. So this becomes square root 2 over 2. Okay, so recall rationalizing. So this also becomes square root 2 over 2. Once you rationalize it, please just keep it to memory that it's just square root 2 over 2. This is a special number. You have to remember square root 2 over 2. All right, so at 45 degrees, it is square root 2 over 2, square root 2 over 2. Because this length is square root 2 over 2, the x direction is square root 2 over 2, and y length is square root 2 over 2. All right. So we keep that in mind, square root 2 over 2. Let's go to the 135 degrees. This is the other 45. We know the lengths of these triangles are square root 2 over 2. Except at 135, it's going negative first and then positive. So negative x and then positive y. So what do you think the coordinate is going to be? Yes. Negative square root 2 over 2, square root 2 over 2. All right. Let's go down to the other 45, the 225. Okay, what's the x and y coordinate on the 225? Negative and then negative.
Negative square root 2 over 2. Negative square root 2 over 2.
Yeah, negative square root 2 over 2, negative square root 2 over 2. And then the last one, the last 45. 315. Positive first and then negative. Yeah. Square root 2 over 2, negative square root 2 over 2. All right, so the 45s are easy because they're all square root 2 over 2s. And all you have to do is figure out, is it a positive x? Is it a negative x? Is it a positive y or negative y? All right, now the hardest one. The 30, 60, 90. Okay, again, 30, 60, 90, we are going to keep the radius 1. So this hypotenuse has to be 1. So what we're going to do is divide everything by 2. So the lengths are going to be 1/2 and square root 3 over 2. So this one's a little bit harder to remember, but I'm going to show you how to remember it a little bit easier. Okay, it's going to be 1/2 and square root 3 over 2. Now, ask yourself, which one is longer? 1/2 or square root 3 over 2? Square root 3 over 2, right? You can already tell that that side is longer, right? So when you look at these special triangles here, what's going to happen is you're going to ask yourself, which side is longer? Okay, so this is going to be a 30 degrees because it says 30. So it's 30 degrees. Now, is the x longer or is the y longer? X. X is longer. So x direction is square root 3 over 2. The y direction is 1/2. Square root 3 over 2, 1/2. Okay, let's look at the 60, this one. Which one is longer, the x direction or the y direction on the 60? Y direction. The y direction is longer, so is it going to be square root 3 over 2 or 1/2? Square root 3 over 2. So this is going to be 1/2 square root 3 over 2. Okay? Once you fill out one quadrant, the other quadrant is just the flip. Okay? It's just exact same numbers except you change the signs. Okay? So for example, at 120, it looks exactly the same as the 60, right? Except you flip it over. So then the x direction is negative, but the y direction, you keep it positive. Okay, I'm going to give you about a minute. Try to finish all the other ones. Just fill it all in. So the easiest way to do this is not actually memorizing the numbers, is just look at the shape and look at how big the numbers are. Okay, and then there's a reason that you memorize these coordinates. And that's because the x direction is cosine theta, or cosine of the angle, and then the y direction is sine of the angle. So this is x and y. So eventually what we're going to do is memorize cosine and sine of that angle. So the way you use it is, for example, if someone asks you, what is cosine of 0 degrees? What is cosine of 0 degrees? You look at the x part. Okay. So go ahead and try your homework tonight, which is going to require the unit circle, and then we'll come back tomorrow and learn everything else.